Hello and welcome. Today we're going to be looking at a question which may or may not be heavily based on a question that was asked in the TMUA 2026 paper 1. This is a recurrence relation question, but it's a slightly unusual one since it's essentially asking us to walk the recurrence relation backwards instead of forwards. So we're told that an plus 1 is 2 minus an over an plus 3. And we're given the 101st term in the sequence, which is 1, but we're asked for the value of the 99th term. So we need to figure out a way to go backwards rather than forwards. Let's think about the information we're given. We're told that the n plus 1th term is 2 minus an over an plus 3. So we can think of this as f of an, where the function f takes x and gives you 2 minus x over x plus 3. So what we have here is a way to get from the nth term to the n plus 1th term, but we want a way to go backwards. What we really want is to go from the n plus 1th term to the nth term. We can notice that this is essentially asking, okay, given some term, what's the input that we gave f? So for example, the 101st term is 1. To figure out the 100th term, we'd have to figure out what we can stick into f to get to 1. Now this might make you think of inverse functions. Inverse functions tell you what input a function was given to get to a certain output. And indeed, if the n plus 1th term is f of the nth term, then the nth term, an, is going to be the inverse of f applied to the n plus 1th term, an plus 1. If we do find this inverse, that's going to let us go from the 101st term to the 100th, and then finally to the 99th, which is our end goal. So finding the inverse of a function like this is something we're taught to do at A level. So that should hopefully be quite routine at this point. We can write x equals 2 minus y over y plus 3, where y is the inverse function. And then if we rearrange for y, we're going to be finding the inverse function. So to start off with, we can multiply through by y plus 3. That's going to get us xy plus 3x, which is equal to 2 minus y. And we're looking for y, so we can stick all the y terms on one side, move the remaining terms over to the right. So xy plus y is going to be 2 minus 3x. And factor out that y in preparation to divide through and get y on its own. So xy plus y is y times x plus 1. And finally, y is 2 minus 3x divided by x plus 1. So we know that f inverse of x is 2 minus 3x over x plus 1. Okay. Well, as we mentioned, the 100th term, 100, is going to be the inverse applied to the 101st term. We're told that the 101st term is 1, so that's f inverse of 1, which is 2 minus 3 times 1. 3 times 1 is just 3, divided by 1 plus 1. And that is going to come out to negative a half. Finally, to get to the 99th term, we can apply the inverse again. So f inverse of negative a half. And that is going to be 2 minus 3 over 2. So 2 plus 3 over 2, divided by minus a half plus 1. To simplify it quickly, we can multiply the numerator and denominator through by 2. So that will give us 4 plus 3 over minus 1 plus 2, which gives us our final answer of 7 over 1, which is just 7. And so what we're looking for is option E. Okay, I hope you enjoyed this problem. I'll catch you all in the next one. Until then, good luck.